All right, so let's actually do something with our robot. So we can get there by clicking on robot and then source editor. Mine's already open. And if you don't have the robot open, you can always get there. So if it's closed, you can always get there by saying File, Open, going to the containing folder, in this case IS, and then opening that robot, in my case Robocode Fun. All right, so how do we know what to do or what we can do in this world of Robocode? They provide for us an instruction manual. And so there's something called an API. So if I click on Help and then Robocode API, APIs, I don't think this is Danish, APIs are used all the time in programming. And so we build a program, whatever, like, the Amazon Alexa or Google Echo or whatever has an API that you can tie into if you want to build an app for that technology. And so it just says, here's the list of classes, here's the list of methods in those classes, here's how you can interact with our hardware in that case. And so all the time we use APIs to work with one technology to tie it into another technology. And as we get further along in programming, we can write our own APIs that we can use with other programs to go, what we say, consume that API, to go get the information from it to do whatever we need it to do. And so we use APIs all the time. And this is the Robocode API. This is the instruction manual for how to use Robocode. And so first of all, this line here, import robocode.*. This goes and gets all of these classes that are related to Robocode. So you bring all of this information in. And then our robot, public class Robocode Fun, extends the robot class. And so if I scroll down this list, there is a robot class that we're inheriting from. And so anything that this class can do, we can do. And so you may, as we start going down looking at the methods, so the methods and properties related to this class belong to us as well because we've inherited that. As we look at these methods, we're going to recognize some right off the bat. So there's an ahead that moves our robot ahead by a certain distance measured in pixels. And so here we're using the ahead and we're passing to it how far ahead we want to move in pixels. And with the API, we might just have that much, but we can also a lot of times click into the detail, and then it gives us more information about that method. So this immediately moves the robot ahead forward by distance measured in pixels. Call executes immediately and does not return until it's complete. It doesn't stop moving until the distance is 0. If the robot collides with the wall, the move is complete, meaning the robot will not move any further. If the robot collides with another robot, the move is complete if you are heading toward the other robot. Note that both positive and negative values can be given as input, where negative values means that the robot is set to move backward instead of forward. And so it just gives us a little detail about it. It gives us the method signature, and it kind of just tells us how to use it. I can call this method ahead, and I can pass it in a certain number of pixels, and it will execute that method for me. There's a back that we've used as well. There's a do nothing if you want to do nothing on your turn. There's a fire, which we're currently doing, and so I can click on fire, and it gives you some information about what the damage it does and everything else, and the bullet's going to travel in the direction the gun's pointing. The power is taken from the robot's energy, so if I shoot with a power of 3, 3 is taken from my energy. On the other end, here's what it's going to do. Damage if it hits another robot, 4 times the power. If the power is greater than 1, it'll do an additional this much damage, and we're going to get back 3 times the power if we hit another robot. So just those rules that we talked about. And so we can pass in the amount of power that we want as we fire, and we can experiment with this too. So if I take and say, with the fire method, I think it was a 1 actually. This is not take 1. Take 16, I don't know where we're at right now. So we can change this, modify it. So I can come in and look at this and say, let's compile it firing with 1 when we scan a robot. And we can run this, and this is really good to test it out as we're working on these robots. So we can go in here and throw some bots into the ring, including ours. So add that one, add corners, add crazy, add fire, and start this battle. And then if we're testing something, I can say, let's just do it at 1,000. Let's go through and see how we did. So we got 5% of the points. All right, let's try this again. Restart. Again, 5%. All right, so I can change the power. And back in the rules, we found out the max power you can fire with is a power of 3. If you say power of 15, it'll just default to a 3. So anything over 3 gets turned into a 3, but 3 is the max we can fire with. So just by making that one change and then compiling again, and then restarting, then my percentage has increased. And if I try this again, all right, I'm back down to a 6. Maybe it wasn't that good of a move after all. There's 10%. So I seem to do better, and I can test this. I love actually Robocode for this. I can go make some changes and just try little things and see if they work better by just making that change and then rerunning it at high speed and then getting the results. I seem to be in the teens more often now, so it seems like it's better to fire with a power of 3. I even got a first place, amazingly. And so anyway, back to the API, there's the fire, right? And so everything that I can do in my robot is listed out in that robot class in the API. So I can get the battlefield width. I can get my current energy to see how much energy I have left. I can see how much gun heat there is. I can get my current heading in relation to the board. Remember our 0, and if I click on this, remember that note that the heading in Robocode is like a compass, where 0 means north, 90 means east, 180 means south, and 270 means west. And so I can go and see what is my heading on this board in relation to that, that grid layout that we talked about. Am I heading north? Am I heading south? I can go find out. Let's see. Going back, I can get the name of my robot. I can get the height of the robot. All sorts of different things. My X and Y position on the board. So there's lots that I can do here. Well, what are all these other classes? These are all things that get called. And so when I get hit by a bullet, so on hit by bullet, then what's generated for me is a hit by bullet event class, an instance of it. So it takes this template of a hit by bullet event, and when that happens, then it passes to me information about that particular bullet. It tells me the bearing of where the bullet came from, the bearing in radians, the heading of the bullet when it hit me, the heading in radians. It gets the name of the person that fired the bullet. It gets the power of the bullet. It gets the velocity of the bullet. So all of this information is packaged up into a snapshot, a bundle, and handed to me when I'm hit by a bullet in a hit by bullet event type object that I'll refer to as E. This is the instance. And the next bullet I'm hit by, it packages up another hit by bullet event called E and hands it to me. And every time I'm getting a snapshot of that information. And so this is the Robocode API. We can use it for all sorts of different things, but just keeping in mind the main things that we can do are in this robot class, because that's what we've inherited from. All right, so in the next video, let's get on to a example that it happens all the time, getting stuck in the wall. Our robot gets stuck in the wall and it can't move. Let's figure out how we can use the Robocode API to fix that problem. Spencer, out.